So Gaussian elimination always makes use of a notation called the augmented matrix. Okay, so let's see what that means. So far you know that any linear system of equations, such as this one here, can be written as a matrix times a vector equals another vector, like we did here. Yes? And you understand how this works. Now, the augmented matrix is really simple. You simply get this matrix here, which is matrix A, which has m rows and n columns, and you put it next to this vector B, which has m rows. So they fit nicely into a single array. So this is how an augmented matrix looks like. So you start with AX equals B, and you write A next to B. Okay, so how would that look like? It would look like this. A11, A12, all the way up to A1n, A21, A22, up to AM1, AM2, all the way up to AMN. And then instead of closing the parentheses for matrix A, we use a vertical line, like that. And then we write the m coefficients of vector B. So B1, B2, all the way up to Bm. Okay? And that's it. That's what we call the augmented matrix. Sorry? Augmented matrix. So the aim of Gaussian elimination is to do operations on this augmented matrix in order to reduce it into something called the row echelon form. And in the next video we will study what this row echelon form is.